For our last program, we're going to introduce the C# equality and relational operators and the if statement, which of course are important for making decisions in your code. So let me go ahead and load up the comparison application from the fig3_18 folder. And for this program, for those of you coming from other C-based languages, a lot of what you're about to see is very similar to those other languages. So once again, we've included the using system directive here because we're taking advantage of the console class and the convert class. In our class called comparison, we have just a big main method that's going to do all the work of this program. And the first thing we do in main is declare a couple of int variables, number1 and number2. Now, of course, there are other built-in data types. For example, you have long for a long integer, which is a 64-bit integer in C#. You have float and double for different types of floating point numbers with decimal points in them. There's also a decimal type, which is for more precise floating point arithmetic, such as monetary calculations. And there are other types as well, like booleans and characters, etc. So we'll be seeing all of those different types as we move through the various lessons. So here we're just using integers for simplicity. We declare a couple of integers, number1 and number2, and just as we did in the addition program, first we prompt the user to enter an integer, then we read that integer in using console.readline. When you call console.readline, it waits for input until you press the enter key or until the end of input character is encountered. So for example, if I type Control-Z on a Windows system, that's going to indicate the end of the input, and that also would terminate a call to readline. Whatever is read in is a string that gets passed in turn to convert.toInt32, which is going to try to convert it from a string to an integer. So I'm assuming once again that the user is entering the value properly, and then we'll store that in number1. And we do the same thing here at lines 19 and 20 for the number 2. So at this point, we have a series of if statements, and I'm actually going to run the program first so you can see those if statements in action. So I'll go ahead and enter the same value twice here, and we can see that 3 of my if conditions were true. 100 is equal to 100, it's less than or equal to 100, and it's greater than or equal to 100. Similarly, if I go run that one more time here, and let's say I do a big value followed by a small value. Oops. I ran that the wrong way because I have to enter it one at a time, so I apologize for that. So 200, 100. Then you can see that 200 is not equal to 100, 200 is greater than 100, and it's also greater than or equal to 100. And then finally, of course, if we put the small number first, we'll run it one more time here. We'll do 100 and 200. And of course, now we see they're not equal. 100 is less than 200, and 100 is less than or equal to 200. So nothing really complex for those of you who are already programmers coming from other programming languages. What's new here is the fact that we're doing it in C#. So we have these 6 simple if statements, each of which has a required if keyword followed by a required set of parentheses containing a condition. The relational and equality operators, the equals operator is the double equal sign, just as in C, C++, and Java, and Objective-C. Some languages use a single equal sign for that. The not equals is the exclamation point followed by an equal sign. Less than and greater than are straightforward, and for any multi-character operator, you always want to make sure you provide them with no space between the characters. So less than or equal to is less than equal sign with nothing in between, and similarly greater than or equal to as well. Now, by default, the if statement expects only one statement in its body, which we've indented in each case. So if number1 is equal to number2, that condition will be true and will execute line 23, at which point the format string has placeholders for number1 and number2 that are going to receive the values of those variables that come as subsequent arguments. So number1's value gets placed in the placeholder for 0, number2's value gets placed in the placeholder for 1. So that will only display if, in fact, these numbers are equal. Now, if I wanted to have multiple statements in the body, what I could do is wrap those in curly braces, as we do in many of today's programming languages that are based on C, and many programmers look at that as a good practice and always use the curly braces as a form of clarity, and also to protect themselves against the future where they may choose to add other statements to the body of these if statements, and if they didn't have the curly braces, they might forget to add them in at that point. For our code, we tend to try to keep the code as compressed as possible vertically because we have limited space in our books when we're doing print publications. So if number 1 is equal to number 2, we'll execute line 23. On the other hand, if it's not equal, then the condition at line 25 will be true and line 26 will execute. And then similarly, you see the conditions for less than, greater than, less than or equal, and greater than or equal as well. So at this point, we've introduced some very basic C# coding. We took a look at how to create a very simple class definition that contains just a main method, and we did that for each of the examples in this lesson. And we've now also seen how to do simple text output, simple text input, and several different operators of C# as well. In fact, this is the full list of operators that we've introduced so far, and the precedence is top to bottom in this diagram. So the multiplication, division, and modulus of the operators, or remainder I should say, of the operators we've shown so far have the highest precedence, followed by plus and minus, followed by less than or equal, greater than, and greater than or equal, and then the the equality operators are next, and the assignment operator has the lowest of the lowest precedence of the operators we've looked at so far. By the way, notice the associativity column for these. For the first 4 rows, they associate from left to right, but in the case of the assignment operator, it associates from right to left. So at this point, we've finished lesson 3. In the next lesson, we start to take a look at the fundamentals of object-oriented programming. In that lesson, we'll talk in much more detail about class definitions, and we'll also start to talk about the public keyword in more detail as well. In addition, we'll introduce several new features to you.